The first example that I want to do, now we're continuing on with finding the area under a rectangle, is just to do a very simple example so that you get the hang of using the sigma notation. So here we're asked to add up all the terms, so there's going to be 9 terms, of the expression 2 to the I minus 1. So what that means is that the very first term is going to be the term with I replaced with 1, and then I replaced with 2, and then 3, and then 4, and then 5, all the way up to I being replaced with 9. And then we simply figure out what all those terms are, just plugging them into your calculator, and then adding them all up. That's how the sigma notation works. And if you do that all correctly, you should get 511 as your answer. If we go on to do that for the second rectangle, the right-hand corner of the second rectangle is going to be at 1 plus 2 over n plus 2 over n, and let's simplify that to 1 plus 4 over n. We plug that into our f of x, so f of 1 plus 4 over n gives us the expression that you see. Now let's try to get generic here. Let's just arbitrarily say we're out at the ith rectangle. And so where is the x value for the right-hand corner of the ith rectangle? It is at 1 plus 2I over n. So let's plug that into the expression for our function, and now we have a generic expression for the height of any particular rectangle. All right, we're going to go on to the next slide. So there's the visual. You can always pause and reverse it if you need to see the visual again. So now we have, since we have this general expression for f of x sub I, all we have to do, according to our formula is the sum of all the f of x sub i's times delta x. Remember, delta x was 2 over n, that's the width of each rectangle. So we take our generic expression, 2 times the quantity 1 plus 2I over n, all over 1 plus 2I over n, that quantity squared, plus 1. That's f of x sub I, times delta x, that's the width of each rectangle, so that's 2 over n. And using the limit definition, we would take the limit of that sum. But this is as far as you have to go. This is the expression for the area under our graph.